All right. Well, good morning and good afternoon, everyone. Welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. Great to be connecting for another SciComm story time. So every day at 2 o'clock Eastern or 11 a.m. Pacific, we join another science communicator from somewhere across North America, whether it's biology, whether it's space exploration, whether it's human health, and we get their story. They share an exciting story with us. They share why they're so passionate about science. It's really been a lot of fun, and we're excited to keep this rolling every day at 2 p.m. for the foreseeable future. With that in mind, great to see so many people starting to join in live. Don't forget you can use the chat sidebar on the right to send us in some questions. Let us know where you're watching from. And let's get things moving to today's event. So today we're connecting with Stephanie Hamilton. She's a planetary scientist and science communicator. As a graduate student, she repurposed a large astronomical survey called the Dark Energy Survey to discover new small objects in our solar system. One of her exciting discoveries was a distant dwarf planet that she nicknamed DeeDee for distant dwarf. After that discovery, she found a passion for science communication, and since then has been writing dozens of articles, worked as a science reporter, and has trained over 500 researchers to communicate more effectively. So Stephanie, it's so great to have you joining us live today. We're excited to get to know you a little bit better. And of course, we'll fire away with a little Q&A action.
Awesome, thanks. I'm so excited to be here. As Joe said, I'm a planetary scientist and science communicator. I defended my PhD just last year, and so I'm finally past the academic life, sort of. I now work at MIT, but I'm not a student anymore. So I just thought that today I would tell you a little bit about how I got here and what sort of sparked my passion in both astronomy and in science communication. So I'm gonna share my screen. Hopefully this goes smoothly. Are we good? Okay, so I'm just going to talk about astronomy, my brief detour into high energy physics for about 4 years, and then science communication. So my story sort of starts out when I was a young girl living in a suburb north of Detroit in Michigan. And one of my favorite things to do when I was young was go up the hill by my house. There was a hill that went into a neighboring subdivision right by my house, and it was just a little bit darker and got above some of the trees that were around my house where I lived. And so my dad often would take me up to this hill, and we would look for the International Space Station. And so I think the actual website I used was something through the Sky and Telescope magazine, but I've also linked NASA's Spot the Station website here, where you can go and enter in your location, and it'll tell you the next time that the International Space Station will fly over you and when it'll be visible. So we did this quite often. And so this sort of sparked my interest in looking up at the sky. And it was just so fascinating to me that there were people on this little moving dot that was going through the sky that was so bright. And there were people up there. And so my uncle was an astronomy teacher, and he had a telescope, the same telescope that you see on the right there. And it wasn't working. And so he told me I could have it if I could fix it. And so me and my dad, we took it down to the basement and we looked at it a little bit, and it turned out that the mirror inside that reflected all the light coming from the sky, it was misaligned. So the light wasn't reaching the eyepiece in the right way. And so my dad and I, we fixed this mirror, we realigned it, and voila, the telescope works. And I still have that telescope, I still use it. It is one of my most favorite possessions because it really enabled me to look at the sky even deeper. It gave me that extra magnification. We could collect more light and see fainter things. And so it just opened up a whole new arena of the sky that I didn't have access to before. And that was just so exciting to me. And so this telescope is one of my most favorite and prized possessions, even though it's small and old. It is my favorite, one of my favorite things that I own. So we're going to fast forward a little bit, well, a lot of it, to when I went to undergrad college at Michigan State University. And when I got to Michigan State University, I got placed with a research professor who was doing high energy physics. So basically looking at what happens when you take protons and small atomic particles and smash them together to see what happens. And so I took a detour from astronomy to start studying high energy physics and looking at these atom collisions and the stuff that comes out. And this led to an incredible research opportunity at CERN, which is located in Switzerland. It's home to the biggest atom collider in the world, the most powerful one. And the summer I was there, they made a very, very, very exciting discovery of a particle called the Higgs boson. And the Higgs boson is essentially what makes everything around us have mass, make it weigh something. And so interactions with this particle at a very small subatomic level is what makes all the particles around us, all the atoms, all the stuff around us have mass. And before the summer of 2012, we didn't know whether it existed. We had hints, we thought it probably did, the data was very suggestive, but we didn't know for sure. And so I had a research opportunity at CERN. I spent a summer in Switzerland working at this lab. And that summer, they made the discovery of this particle. And so there was a huge press conference, a big announcement presentation. And so the pictures you see here on the screen are what the line looked like to get into the auditorium. So for context, I got up at 2 in the morning to start standing in line. I might as well have not gone to bed. I was so tired and I did not get any sleep. You can see people in blankets laying on the floor trying to sleep. And we were far from the first people in line, and we got in line at 2 in the morning. And so this auditorium only had about 150 seats open for just general people to go in and watch the announcement. The other 150 seats in the auditorium were reserved for, fancy, important people. And they didn't have to wait in the line. They could just show up and they got a seat in the main auditorium. And so I started waiting in line at 2 a.m. I think I watched about 2 movies, trying to sleep unsuccessfully. And then finally in the lower left is when they opened the door to the auditorium and everyone stood up and started rushing toward the door. And I got a seat in the main auditorium. I was probably the second row from the top. So I almost didn't get in. Probably if I had got in line at 3 in the morning instead, I would not have gotten a seat in the main auditorium. And so the picture on the lower right there is me completely sleep deprived, but excited out of my mind to witness this historic discovery in person. So this event was being live streamed all over the world, but I and some of my research internship friends got to see the announcement from inside the auditorium itself. So that was super exciting and is one of my favorite memories from all of my research experiences, getting to witness this historic discovery announcement. And so that really ignited my excitement for science all over again. And I continued through undergrad with high energy physics, I think sort of riding the wave of this excitement and this incredible research opportunity at CERN in Switzerland. And then I went to graduate school and I left my advisor, who I really, really enjoyed working with at Michigan State. His name was Joey Houston. And he was a fantastic advisor. But when I got to graduate school, I realized that I had stayed in high energy physics to work with Joey. And not because that was really where my scientific passion lied. So when I got to graduate school, I decided I wanted to try to go back to astronomy. And so specifically, I ended up in a group that was doing planetary science. And so I went from my small childhood telescope now to this giant telescope on the right that's 4 meters in diameter. So almost 15 feet, 12 or 15 feet in diameter is the size of the mirror. And what I'm pointing to in that picture is the digital camera that we use to take pictures. And so this is much bigger than a handheld digital camera that you might use just to take pictures in your everyday life. And this is the output that comes off of that camera. So each of those rectangles is a CCD chip on the camera. And there are 62 of them. A couple of them don't work anymore, but the majority of the 62 CCDs still work on this camera. And so what I was doing was I was looking at these images, looking for tiny little points of light. And the points of light that I was looking for, you'd have to zoom way, way, way in on this image to even see them. The points of light that you see here are bright stars and galaxies. But we were looking for little points of light that moved kind of like this. So this is an image of the night sky at 2 different times. And you can see that there's a dot here that's moving. And so what that tells us is that that dot is in our own solar system. It is close to us. And so one way you can think about this is if you hold your finger in front of your face at home. I want you to do this with me. You hold your finger in front of your face. If you hold it really close and you blink one eye and then the other and then the other, you can see that your finger moves quite a bit against the background. Now, if you hold your finger out at arm's length, much farther away, and you blink one eye and then the other eye and then the other eye, your finger moves a much smaller distance, right? So the distance that your finger moved, or the distance that, for example, this point of light moves, tells us how far away from us it is. And so this particular point of light that's moving was the second most distant solar system object that had ever been found, ever. And so that was extremely exciting to us. It was about 2.5 times farther away than Pluto is. And Pluto is extremely far. It took the New Horizons spacecraft 9 years to get there. And so it would take much, much longer to get to this object. So one of the reasons we were really excited about this object is because it was the second most distant object that had ever been found, yet it was still visible on our CCD chips, which meant it was, somewhat bright, which meant that it was potentially big, but we didn't know how big it was. So how do we figure out how big this object is? There's a little bit of an issue in that our digital camera was taking pictures in visible light, so light that your eyes can see. And in visible light, if I can get my pointer, you can see here, we have 3 objects of different sizes, but they reflect a different amount of light. And so this object is small, but shiny, whereas this object is large, but dark. I hope you can see the pointer. But if we look down here, this is an example of what the picture would look like. All these 3 points look the same. So just from the visible light, the light that our camera detects, we can't tell whether this object is small and shiny or large and dark. So this is, again, that image. So this is our image in visible light. We can't distinguish between these 3. But if we look at infrared light, or basically heat, now we see that these objects, these 3 different objects, if it's small, it's much fainter in the image, whereas if it's big, it's much brighter. So this is how we can tell how big this object is. We take additional measurements of its heat signature. Believe it or not, way out in the depths of space, you can measure the heat coming off of something. It's not a lot of heat, but it's more heat than empty space. So that's what we needed. We had these measurements already, this visible light. We needed these infrared or heat measurements, and we got them. So that's what this object looks like now. That's its heat signature against the background of space. And so now with those 2 measurements, we can calculate a size for this object. And so, as you might have guessed, this object is the distant dwarf planet candidate that my research group found, called DeeDee for distant dwarf. And I calculated its diameter to be 640 kilometers, or 330 miles in diameter. And it reflects about 13% of the light that hits it. So for context, it's about the size of the US state of Oregon. And it looks sort of like asphalt, or roughly asphalt. And so that was probably the most exciting discovery of my entire graduate school career. And it led to a number of different things. So the first thing this was really my first leap into science communication. So excuse the picture quality, it was dark, but this was my first public talk opportunity, and it was in a planetarium. So I got to give a talk where my slides were projected on the planetarium dome, which was super cool. And I had so much fun doing this that I couldn't get enough. I wanted to do more. I wanted to do more public talks. I wanted to share exciting astronomy research with other people. So this is now a demo that I created and put on at the Detroit Zoo, along with several other scientists, which you can see in the background. And so I was demonstrating how big the solar system actually is. And so kids would walk by and I would hand them this piece of string that I'm holding, which hopefully you can see, that had the planets spaced out with the distances to scale. And I would have them walk away from me so they could see how big the solar system actually is. And this is my wonderful mother who came to support me when I was sharing my science. This is a picture of my PhD defense day. I love this picture because it is really the pinnacle of my entire graduate school career. Obviously, it's my PhD defense, but like, look at this dress, it's amazing. And then finally, this was over the summer, last summer in Indianapolis. And I'm not usually a tree hugger, but I do hug trees when they've been to the moon. So this tree is one of the famous moon trees that the seeds of these trees went to the moon with Apollo 14, the mission Apollo 14. And so these trees are scattered all over the country, and one of them was in Indianapolis. And so I went and I found it and I hugged it, because what else do you do with a moon tree? So my science communication journey also continued into science writing. So I was an author for the site Astrobytes, which is an incredible collaboration of graduate students who summarize astronomy papers every day. And that led to a mass media fellowship where I worked as a science reporter for a summer. That was the summer I spent in Indianapolis. And as part of that summer, I got to visit that moon tree. And now I am a technical communications associate at MIT, where I help coach researchers on communicating their science more effectively. And I'm also writing science articles about cool engineering research that's happening at MIT. So that's my journey, and I am more than happy to take some questions.
All right, awesome, Stephanie. Thanks so much for sharing your journey with us. You know, what I loved about what we just heard was your passion, how passionate you were for space, how you knew it's what you wanted to do, and you went for it. You know, I think people can talk themselves out of their dreams sometimes and settle for something less than what they wanted. So I think that's a really important message for students is, if you're passionate about something, if you love doing something, you don't give up and you find a way to make it happen.
Yeah, I took this detour to high energy physics, which was amazing, and it taught me so much. But ultimately, I realized that no, astronomy was really my childhood roots. I have loved astronomy since I was a kid, and I wanted to get back to that.
All right, awesome. Well, I can see we have groups tuning in via YouTube, so I can see some questions that have already come in via the chat. I do want to introduce Mrs. Eyre, who's joining us from Toronto, Ontario. She is educators joining from General Career School, and I can see lots of them talking to each other in the chat sidebar as well. So keep your questions coming, and I'm going to pick on your teacher in a minute and get her to relay some of those questions to us. And I also want to give a shout out to Mrs. Yarwood's class in Hamilton, Ontario. They're tuning in all from their homes, and this is their first time giving this a try. So great that you joined us, and we look forward to seeing some of your questions as well. And Stephanie, I was pretty impressed with the moon tree. I'd never heard that before. That was a fact that I hadn't heard, that there were seeds brought to the moon and then they planted them. That's pretty wild.
Yeah, I mean, they wanted to see what the environment of space and lack of gravity would do to how these trees would grow. I don't think it really affected them. I think they're growing just fine. But with the 50th anniversary of Apollo 11 last summer, there was a lot of coverage around these moon trees. And so I before that, didn't know that there was one in Indianapolis. And once I found that out, I was like, I have to go find the moon tree.
All right. Very cool. All right, Mrs. Ayer, let's put you on the spot as you have a question or two for us from your group.
I do, thank you. I have some students joining us from General Career. Stephanie, they are Jasmine in Madame Savoy's class, Jadina in Ms. Kelly's class, and Andrew in my grade 6-7 class. And they've been sending some awesome questions. Jasmine is wondering, who was the first woman astronaut and how big is the solar system?
Ooh, I believe Sally Ride was the first woman astronaut, wasn't she? Pretty sure. I confess I am not as up to date on my astronaut facts as I should be. But as for how big the solar system is, it sort of depends on how you define what the solar system is. So there is a boundary where the sun's influence sort of ends, where its magnetic field and its protection of us and the rest of the solar system sort of ends, and you get out to the mysterious interstellar space. So that boundary is about 125 astronomical units, which an astronomical unit is the distance between the sun and the Earth. And so 125 of those is about where that influence ends. And NASA's probes, Voyager 1 and Voyager 2, have crossed that boundary. So Voyager 1 and Voyager 2 are now out of the solar system.
All right, and you were bang on, Stephanie. It was Sally Ride.
Okay, good. I'm glad I didn't mess that one up.
No, you nailed it. Good job. Let's see. So we've got Amber joining us, and Amber's curious about traveling to Mars. What are your thoughts on that? Do you think it's possible?
I do think it's possible. I think there is a lot we need to learn about how the human body responds to leaving the protection of Earth. So Earth is very protective. It has a magnetic field that shields us from a lot of bad things. And so once we leave that, we don't really know what happens to the human body. And so there's a lot more research that needs to be done before we can just send people to Mars. But I do think that we will get there.
All right, great question. Let's see. Well, Mrs. Yarwood says she loves the dress. I should pass that on from the comments. So that's pretty darn cool.
Fantastic dress.
Let's see. Oh, here we go. So Jadina's joining us. And she's wondering about Pluto. What does it mean when we call Pluto a dwarf planet now, or a dwarf now that it's lost its status?
Yeah, so that is still a point of contention, even in the astronomy community. There are people who still argue about this. But I'm not gonna get into that debate, but what it means to be a dwarf planet is that Pluto is not big enough, it doesn't have enough gravity to clear its orbit, which means that there are other things that share a similar orbit to Pluto that are, a similar size and generally very similar to Pluto. Pluto itself is special though, because it is quite large. It is one of the largest objects out there. And so it has different properties. It doesn't quite fit in with those other objects out there either. It's sort of its own thing. And so that's why there's a new category that was created for it called dwarf planet. It's geologically active, except instead of molten rock, it is molten water. And it is a very interesting place. It doesn't quite fit in with the planets, but it doesn't quite fit in with asteroids and other small bodies either.
All right, you're right. It is controversial, and I know there's campaigns to make Pluto a planet again. So
yes,
in the next little while. Let's see. Okay, so this question here is looks like from Mrs. Yarwood, and she's wondering about an article that came out recently about the Kepler telescope showing an Earth-like planet. Do you know much about exoplanets that maybe have features similar to Earth, or at least from what we can see?
Yeah, so I didn't really study exoplanets as a graduate student. That wasn't my expertise, but we have found a fair number of what we think would be Earth-like planets. I believe the problem is it's really, really hard to study what these planets are made out of. You can, depending on your measurement, you can relatively straightforwardly get either how big the planet is or how massive it is. But it's really hard to figure out if it has an atmosphere, what the atmosphere is made out of, if there's water or something on the surface. It's really hard to get those finer details. And so I don't know much about this recently discovered one, but I think they found that it's about the size of Earth or a Venus, but it's closer to its star, so they think it's probably warmer than an Earth would be. But to be honest, it's really, really hard to get these atmospheric details.
Yeah, absolutely. So it's that, I'm sure students have heard of that Goldilocks zone term, right? Not too far from the star, not too close. That's definitely a good search criteria. But it's just amazing the technology that we're developing, that we can already kind of spot these distant worlds, and that we're getting closer and closer to being able to, definitively peer to their atmospheres. And it's pretty wild.
Yeah, one of the most amazing things is that we can actually directly take pictures of these planets now. So you can basically block out the light from the star, because otherwise the star totally drowns out the planet. But if you can block out that light, you can actually watch the little dot of the planet orbiting around the star. And that wasn't possible even probably, I don't know, 10 years ago.
All right, awesome. So we've got a question here, came in from Samuel, and he's wondering, in your opinion, what do you think one of the most important astronomy questions will be for our next generation of scientists?
Ooh. I'm a planetary scientist, so I'm a little bit biased. I want to know what Neptune and Uranus are like. I want to know more about them. But in terms of astronomy in general, I think the biggest questions now are, what is dark energy? This mysterious force or energy or something, we don't exactly know what it is, that is making the universe expand faster and faster. And then what is dark matter? This also mysterious but unrelated to dark energy thing that keeps all the galaxies together. It basically has the opposite effect of dark energy. We don't know what either of those two are, and they make up 96% of the universe. So I think those are the biggest questions to answer.
All right, those are two pretty good questions.
Yes.
For me, I want to know if there's other life out there. And I have no doubt that there is. There's just too many planets, too many stars. I mean, the numbers are astronomical when you add them up. That there must be other life out there, and it would be amazing when we can definitively say that. That'd be pretty cool.
Yes, that is another excellent question that needs to be answered.
All right, let's see. So a lot of students tuning in today are in grade 6, and in grade 6, the curriculum here in Ontario anyways, is space. So what advice would you have for grade 6 students who might want to follow their passions in science, especially planetary science?
Keep working hard, keep following that passion, study math. It's okay if you're not good at math, but if you work hard and try to understand it, that will take you a long, long way. And then, of course, don't forget to go outside and look up at the stars and maintain your curiosity.
I love that. Sometimes you might have to get a little away from your home. Sometimes in the city.
Yeah, especially if you're near Toronto.
But when you get away, it's worth it, because it is.
Oh, yes, absolutely. I still remember the first time I saw the Milky Way galaxy, when I was finally in a spot where it was dark enough. It was just the most amazing sight I've ever seen.
All right, very cool. Let's check in with Mrs. Ayer one more time and see if there's another question or two.
Hi. Yeah, we have a question from our Google Classroom sent to me. Stephanie, how much would you estimate is the cost of that huge telescope with the huge digital camera on it that you work with?
Ooh, I should know this. I think the camera itself, I don't want to say a wrong number, tens of millions of dollars to hundreds of millions.
Wow.
Yeah, they're very, very expensive. And yeah, just the camera, I think, was tens of thousands of dollars. That's not even counting the big telescope it was attached to.
Great.
All right.
And we have another question from our
Go ahead.
classroom. So now on Earth, the whole entire planet is totally talking about viruses, like the coronavirus. Are there viruses in space? Do you know?
Maybe. I don't know. I'm not sure how long a virus would be able to survive in an environment like space. I think probably the radiation would destroy it pretty quickly. There's a lot of high energy subatomic particles that are flying around and breaking stuff up. And I don't think a virus would last all that long out there. But there are these really cool animals or microscopic organisms called tardigrades, which are super cool. They're also known as water bears. You should look them up. And they can survive in space. So who knows? I don't know. Maybe.
You know what though? That's an awesome answer, because it just shows how much we still have to learn about space and how so many, potential careers there are for the future. And good scientists go out in the field with a handful of questions and come back with 100 more. So
yes. Oh yes.
That's good science. Yeah, absolutely.
Jasmine, if I could add from General Career from Madame Sava's class, is letting you know that she learned in National Geographic that astronauts bring some technology to Mars already.
I'm sorry, what?
That astronauts bring technology to Mars already. She learned that from National Geographic.
Yeah, there are scientists who have sent lots of robots and rovers and stuff to Mars. And there's also some training sites on Earth. I think there's one in Hawaii where astronauts go and essentially pretend like they're on Mars. Wow. And sort of live as if they were on Mars to train.
That would be neat to look up on National Geographic or something like that too then.
Yes, yeah. Yes. That is such a fascinating experiment. I think it's run by NASA.
Wow.
All right, very cool. So we're going to wrap up with one more question for you, Stephanie. And this one's about who inspires you. So I know growing up, I was inspired by David Attenborough, Jacques Cousteau. That's why I became a diver. That's why I've been so passionate about biology and science. So who inspires you?
Ooh, well, my mother, I think, is one of the biggest ones. She is a woman in STEM. And so I always felt like that was a career path that I could take. She's an automotive engineer. So she, I think, was my first role model. And I never felt like I couldn't do science. And then in terms of astronomy, I think Katherine Johnson is a big one for me. She was one of the people who helped get astronauts to the moon. And also Carolyn Herschel, who was a lot of the muscle behind William Herschel and all his famous astronomy discoveries.
All right, excellent. Well, before we wrap today, huge shout out to those who tuned in via YouTube and those who will catch the recording afterwards. Thanks for hanging out with us today and keeping the learning going at home. Obviously, a huge shout out to Mrs. Ayers group joining us from Toronto, Ontario, and Mrs. Yarwood's group joining us from Hamilton, Ontario. Great to see your group so active in the chat. And Stephanie, thank you so much for spending some time with us, sharing your passion with us, and no doubt inspiring a few to peer a little bit deeper into that night sky, hopefully tonight, tomorrow, whenever we get a nice clear night.
Yeah, thanks so much for having me.
All right, awesome. Well, thanks again, everyone. We're going to sign off for today.